So for example 1, there's going to be 3 grade 11s and 2 grade 12s who need to be seated in a row. Okay, 3 grade 11s, 2 grade 12s, everybody's sitting in a row. Okay, in how many ways can the 5 students be seated? So for the first one, we're not worried about putting them in any order or anything like that. We've got 5 people that need to be seated in a row. How many ways can they be seated? Guys, 5 people. Sorry, draw. We're going to say 5 factorial. On your calculator, 5 factorial. Teacher Sam, who I've been chatting to this week, said to me that I need to make you guys do the calculations. So 5 factorial, what do you get when you do 5 factorial? Please, on your calculator, you're more than welcome to submit it in the chat for me. Let's go. 5 factorial, what do we get? Come on, there's 4 people here. One of you has a calculator. Thank you, Lebo. 120. All right. Now, one of the grade 12s is dating a grade 11. Okay. In how many different ways can they sit in a row if the couple must sit together? Okay. So, what's happening here? We got a whole love seat situation happening here. Okay. So, in other words, here is a grade 11 and a grade 12, and they've decided they want to sit together in one chair. So I've made it like a little chair there. All right. And then here's another possibility. Here's another possibility. Here's another possibility. All right. How many chairs we got? 1, 2, 3. Wait. No, oh, sorry. Apologies, guys. Getting ahead of myself here. Come on. All right. So here are my two lovebirds sitting together. Okay. Then I've got another student sitting here. So either a grade, so let's call it a grade 12. Then the other grade 11 and the other grade 11. Let's just say they're sitting in that order. All right. So first of all, okay, how many chairs have I now got? Whether it's a love seat chair or a chair. How many chairs are there altogether if I count it? I've got 1, 2, 3, 4 chairs now. Do you agree? Okay. So I've now got 4 chairs, whether it's a love seat, whether it's a normal chair, I've got 4. Or you could kind of call them blocks as well. You could turn them into blocks if you really wanted to. So 2 people are sitting on a block, okay, because they want to sit together kind of vibes. All right. But I've got 4 factorial. So there's my 4 chairs or my 4 blocks or whatever you want to call it. Okay. Now, within this block over here, okay, within this block, do you agree that there's 2 people sitting in that block? And those 2 people, they can shift position. They can shift position. So this couple, okay, they can also go and they can shuffle around. So either one can sit on the left or the other one can sit on the left or the other one can sit on the right and the right. And so technically, I'm going to have 4 factorial times 2 factorial. And 4 factorial times 2 factorial, what's that going to give me? How many different options have I got now? I've now got 48. Okay. Is everyone good? Does everyone understand what's happening here? Anyone who wants me to explain it again? All good? Awesome. Thank you, Lebo. Okay. In how many different ways can they be seated if the grade 11s must sit together and so must the grade 12s? Okay. So now we're getting into what I call blocks. Now we're really getting into blocks here. Okay. So now, all right, all the grade 11s need to sit together. How many grade 11s do we have again, guys? 3. So we got 3 grade 11s, and they all need to sit together. And I've got 2 grade 12s. Okay, I've got 2 grade 12s, sorry. And they need to sit together. So, first of all, okay, this is a block, and this is a block. So I like to make lists to help myself. So in terms of blocks, how many blocks have I got? In terms of blocks, help me out. How many blocks have I got, please? In terms of blocks, how many blocks have I got, guys? Come on, grade 12s. Thank you. 2 blocks. So I'm going to have 2 factorial because those can be shuffled around. Okay. Grade 11s. In terms of grade 11s, how many grade 11s do I have? I have 3 factorial. In terms of grade 12s, how many grade 12s do I have? I have 2 factorial. So I'm going to have 2 factorial times 3 factorial times 2 factorial. And when I do that sum, that gives me 24. Okay. In how many different ways can they sit? If only the grade 11s must sit together. So now, here's my first block. There's my 3 grade 11s. And then I've got a 12 here, and I've got a 12 here. So I'm still counting these as blocks. Block, block, block. Okay? So, in terms of blocks, how many blocks have I got now? I've got 3 blocks. Okay? In terms of grade 11s that are sitting inside that block, I've got 3. Do I have grade 12s sitting inside the blocks? Yeah, I do, but it's only like 1 grade 12 is sitting in the block and 1 grade 12 is sitting in the block. So do I need to do a factorial calculation? Well, I could go say 1 factorial, 1 factorial, but what a waste of my time. So 3 factorial times 3 factorial is going to give me what? What's 3 factorial times 3 factorial? That gives me 36. Okay. And finally, in how many ways can they be seated if the grade 11s and grade 12s alternate? In other words, I want to have a grade 11, a grade 12, a grade 11, a grade 12, and a grade 11. Okay, so I don't want them to just be sitting wherever they want. I want grade 11, grade 12, grade 11, grade 12. Okay, so I don't want to have 5, 4, 3, 2, 1 options. I want to have 3 grade 11s, 2 grade 12s. And when I do that, how many options do I get? Okay, 3 factorial times 2 factorial gives me 12. Okay, I hope that this block thing is making sense because we're going to use it a lot tonight. I like blocks. You could do it as groups rather instead of blocks. You could say groups, but I like blocks. Okay. All right. Joy, welcome. Okay, we've been working on our so Joy's just joined class as well. We're working on stepping up our counting principle tonight. All right, let's have a look at example number 2. So 4 history books and 3 geography books need to be placed on a shelf. In how many different ways can you arrange the books on the shelf? Guys, I got 7 books. 3 plus 4 gives me 7. Okay, I need to arrange these on the shelf. Doesn't say what order they need to be in. They can be in any order. I've got 7 books, so 7 factorial, and this always freaks me out, that 7 factorial, okay, gives me 5,040. Okay, that 7 books can be arranged in 5,040 different ways. It's just weird to me. But anyway, it's true. Okay. Okay. All right. So, if all the history books must be placed together, okay, and all the geography books must be placed together, in how many ways can the books be arranged on the shelf? Are we doing the same thing? This is the same thing as the grade 11 and the grade 12 question, okay? This is the last one I'm doing with you, and then I'm going to give you an opportunity to try by yourself, okay? But are we doing the same thing here? Except before we were talking about people, now we're talking about books. So I've got 2 blocks. Okay, here are my 4 history books. Here are my three. Oh, my pen is going flat. Sorry, guys. There are my three geography books. Here is block 1, and that's a block. Okay. So, in terms of blocks, I've got 2 factorial, 2 blocks. Within block 1, what do I see? I've got history, and there's 4 different ways to sort that out. Within block 2, I've got geography, and there's 3 different ways to sort that out. So 2 factorial times 4 factorial times 3 factorial. Okay, what do you get? What do you get? 288. Okay, last one together, and I'm going to give you some to try by yourself. So, if just the geography books must be together, how many ways can the books be placed on the shelf? So, just the geography books need to be together. 3 geography need to be in a block, okay? Which means 1, 2, 3, 4. History, 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 history. Block, 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 block. Right. Blocks. How many blocks do I have? I've got 1, 2, 3, 4, 5 blocks. Okay. Within the first block, I see I've got geography. 3. Within block 2, I've got 1 history book, so I could go say 1 factorial. Within block 3, I've got 1 history book, so I could go say 1 factorial. But can you see I'm wasting my time? I don't want to do that. So I'm going to say 5 factorial times 3 factorial, and that gives me 720. Right, does someone have a question? I can hear someone's mic on. Are we all good? No one, are you sure? Okay. All right, guys. So I'm going to give you an opportunity now to try practice this block thing by yourselves. If you're all good and you all think you're okay, hopefully I've taught you something new for some people. All right. If not, let's get you to try go and practice what we've tried to learn now. Okay. So go give it a try. Okay. I don't know how many of you stay in Cape Town, guys, but it is freezing cold here at the moment. And so tea is essential. When you are practicing for maths, tea, it's needed. All right. Maybe coffee is your choice, but tea is what I have when I do maths. Makes life much easier. Okay, I'm going to give you a good few minutes to try this out. Okay. It's not too bad. Very similar to what we've been doing before. Pretty much identical. All right. Still giving you a few more minutes, not rushing you. Okay. One more minute and then we're going to do it together. All right, guys. I think I've given you quite a bit of time now to get this done. No one's asked me any questions, so I'm assuming that you're all good. So let's go work it out. Okay. So it says I have 2 different history books, okay, 3 different geography books, and 2 different science books. It's quite important that it's saying different each time, okay? And they're on a bookshelf. How many different ways can they be arranged? So again, they're not giving us any restrictions for the first bit. So 2A, if I go add them all up, I've got 2 plus 3 is 5, plus 2 is 7. So 7, okay, all right. And we're going to get 504. All right. All good? All get the same answer as me? I hope so. Okay, number 2. What about if I want to arrange them in the same subject and place them together? Well, how many subjects do I have, or groups, or blocks, or whatever you want to call them? I've got 1, 2, 3 blocks. So I'm going to have 3 times by, right? Within the first block, I've got 2 factorial. Within the second block, I've got 3 factorial. And within the last block, I've got 2 factorial. So when I do my calculation there, okay, I'm going to have 144. And finally, I have some people sitting on a bench, okay, and I want to put them all together, sitting in their nationalities. All right, so again, I need to count how many blocks I've got or groups I've got. I've got 1, 2, 3, 4. So 4 factorial times by, apologies guys, my pen's running out, times by 3 factorial times by 4 factorial times by 4 factorial times by 2 factorial. And when I do that on my calculator, I get, apologies, 165,888. Okay, nice and easy. All right. Next one for you to try by yourself. I've got a packet of sweets. It's got red sweets. It's got green sweets. How many ways can you line up the sweets if all the red sweets must be together, all the red sweets must be together, and all the green sweets must be together, and then the color of the sweets must alternate? Okay, so the color of the sweets must alternate. Go give it a try for me. Go give it a try. I'm going to give you 2 minutes. Giving you 2 minutes here. All right, I'm giving you 1 more minute. Okay. All right, guys. Very quiet class. Very, very quiet tonight. Let's go give it a try. So I've got a packet of sweets, 4 red sweets, 4 green sweets. What happens if all the red sweets need to be together? So if all the red sweets need to be together, that means I'm going to put them in a block, okay? So here's my 4 reds, which means what's going to happen? My 4 greens are going to each be in their own blocks. Okay, so how many blocks do I have? I'm going to have 5 blocks. Okay, within my red block, inside of there, I'm going to have 4. And then I could go and say 1 factorial, 1 factorial, 1 factorial, 1 with all the greens, but that would be wasting my time. So I'm going to go say 5 factorial times 4 factorial, and that's going to give me 2,880. Okay. All the red sweets must be together and all the green sweets must be together. That makes my life so much easier because now I'm going to have blocks, 2 blocks. Within red, I'm going to have 4, and within green, I'm going to have 4. Why I'm saying it's going to be so much easier because it means I don't have to draw something. I can picture it in my head, or you can draw it. Draw it if you want to. So I've got 2 factorial times 4 factorial times 4 factorial. And when I do that, I get 1,152. Let's see what you did for the next one. Okay. So for the next one, I need to have the sweets alternating. Okay, so I need to have the sweets alternating. A little bit different to the grade 11 and the grade 12 one. And I'm going to show you why. Because number 1, I can either have red, green, red, green, red, green, red, green. Hey? 1, 2, 3, 4. Or I can have green, red, green, red, green, red, green, red. Okay, so I can either have them going the one way or I can have them going the other way. Either which way they go. So if they go this first way, I want to have 4 factorial times 4 factorial because I want them to be in order. So for the first one, 4 factorial times 4 factorial gives me 576. But if I want them to start the other way, guys, if I want them to start with the green first, then it's still going to be 4 factorial times 4 factorial, which gives me 576. And when I add those up, 576 plus 576, what do I get? What's 576 plus 576? What do I get when I add those two up? Come on, I don't like talking to myself. I get 1,152. Okay. All right. Let's move on to something different for tonight. We're going to look at the word probability. Okay. A little bit different to what we were doing before. Little bit different to what we were doing before. Okay. So let's look at the word probability. If we're looking at the word probability, all right, I've got, give myself a little bit of space, but I don't want to. Okay. So I've got the letter P. I've got one of those. I've got the letter R, one of those. O, one of those. Then I've got the letter B. Okay. Do you agree that in the word probability, there's two B's? The letter A, one. Okay. The letter I, I've got two of those again. The letter L, one. T, I've got one. And Y, I've got one. Now, altogether, okay, yes, altogether there are 11 letters in the word probability. So if I want to determine the number of ways that the letters can be arranged, okay, so the number of ways I can arrange the different letters, then absolutely 11 factorial, because there's 11 different ways that I can arrange the letters, 11 factorial. However, what do I know about two of the letters within that word? They are repeated. So guys, when you have a word and it's got repeated letters, you need to be a little bit careful here. 11 factorial, absolutely. I agree with you. That is true. Absolutely. All right. However, the B is being repeated and the I is being repeated. So when we do this calculation, we need to make sure that we're dividing by those two times by each other. And when we do that, we get a figure of 997, 200. So again, if you have repeated letters in the word, or it's mainly with letters. Okay, you're going to make sure that you divide by them on the bottom. Okay, what happens if the word needs to start with a B now? What happens if you need to start the word with the letter B now? Well, if you're starting the word with the letter B, then on the top, what does it mean? Now you're only going to have 10 more options on the top. And on the bottom, okay, if you're starting with a B, that means, are you going to be repeating one of the B's? No, because now you've started with a B, so you're just going to use one of the B's again. So that means that you're only going to divide by the repeated I. And so when you do that calculation, you're going to get 181,4400. And the last thing I need to do is I need to calculate the probability that the word starts with a B. So the probability that any word that I pick starts with a B, I'm going to take 181,4400 divided by 997,200, and I'm going to get 2/11. Okay, because I have two B's, yeah, out of 11 letters. 2 B's out of 11 letters, 2 out of 11. All right. Are you all good with that? Anyone who wants me to go over it again, can you give me a sign of life? Can I have a thumbs up? Can I have a yes, all good, ma'am? No, ma'am, explain it again. Joy has raised her hand. Joy, go. Talk to me, Joy. How can I explain it again? Do you need help? Go ahead. Unmute yourself. Joy, was that a...
Evening, ma'am.
Evening. How are you?
I would like to know, how do you know when you're supposed to like put in the factorial, or yeah, that's my question.
How do you know when you must put in the factorial? So, Joy,
Yeah.
when you must know you must put in the factorial is when you've got something like so like if you've got chairs or you've got seats or you've got like, and it's going like 4, 3, 2, 1, then rather than doing like on your calculator 4 times 3 times 2 times 1, it's so much easier to just press 4 factorial. Or like you've got those 7 book options that we had just now. And rather than saying to yourself 7 times 6 times 5 times 4 times 3 times 2 times 1, 7 factorial. So much easier. Okay, Joy, there's nothing wrong with saying on your calculator 7 times 6 times 5 times 4 times 3 times 2 times 1. Great tells there's nothing wrong with that. However, what's the likelihood that you're going to make a mistake? Highly likely, hey? Okay, so it's whenever, okay, you've got that kind of situation happening where you've got like these options where you've got you're going to fill spots or you're going to fill places, or you're working out like the number of options, those kinds of questions where you're going to use the factorial. I hope that answers your question, Joy. Thank you so much for the question. Thank you for showing signs of life. I love it. Okay. All right. So, example number 5. For some reason, I believe that Miss Teacher Sam meant to put this probability calculation up here for you. I'm thinking, but I'll leave it there for her anyway. You never know. Maybe. Okay. So, a combination Turlock is formed using 3 letters of the alphabet, excluding, okay, O, Q, S, U, V, and W. All right. So, it's formed using any 3 letters of the alphabet, excluding, so except for those letters, and using any 3 digits. All right, any 3 digits. So remember, if you're looking for digits, you're normally looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Hey, those are your digits. The numbers and letters can be repeated. Cool. Calculate the probability that a combination chosen at random starts with the letter X and ends with the number 6. Oh, that is a tricky one. Okay, that's a tricky one. All right. Let's think about it. Okay, let's think about it. Okay. So, first of all, how many letters in the alphabet? There are 26. All right. But what do we know here? But we know that we can't use O, Q, S, U, V, or W. So 1, 2, 3, 4, 5, 6. Okay. So we only got 20 letters to work with. Okay. It says that the numbers and letters can be repeated. So it's not like once we take a letter out, we can't repeat it. So Joy, this is a really good example with factorials. If we could have repeated it, then we could have used factorials here kind of, but we can't in this case. Okay. So yeah. All right. So this is one of those situations where we're not going to be using our factorials in this situation. Okay. Because here we can repeat the letters. Okay. The numbers can also be repeated. We want to calculate the probability that if we choose a number, calculate the probability of a combination chosen at random, starts with the letter X and ends with the number 6. So first of all, let's go calculate how many combinations we've got. Right. So we've got 3 letters of the alphabet. So 1, 2, 3 of the alphabet, and 3 digits. 1, 2, 3. Okay, We know there's 10 digits. Why am I saying 10? Because it's 0 to 9, which makes 10 digits. Hey, remember we spoke about this on Monday? Okay, and we've just worked out that we got 20 letters to work with. So here, I've got 20 letters that I can work with. I'm still going to have 20 letters. I'm still going to have 20 letters here. Okay, so those are my letters. In terms of my digits, how many digits have I got to work with? 10, 10, and 10. So what's my sum going to look like? 20 times 20 times 20 times 10 times 10 times 10. Hey, guys? Okay, so my possible combinations here are 8. How many zeros have I got? 8, 1, 2, 3, 8 million. Wow. Okay, so I got 8 million options here. All right. Now, okay, I need to work out what's the probability that's going to start with an X and end with the number 6. Okay, so the probability that it's going to start with an X and end with the number 6 is what? Okay, start with an X and end with a number of 6. So those are our total number of combinations. All right. If I want to calculate what my remaining are, okay, so I'm just going to go calculate it down here. Okay, so in other words, 1, 2, 3, 1, 2, 3. Well, if it's starting with an X, that means I've only got one option here, hey? X, one option. But here I've still got, oh, okay. Apologies. All right. Then it's not telling me that I can't use an X again. Am I right? It's not saying you can't use, it could be X, X, and X. Starts with an X and ends with the number 6. So I could still have 20 and I could still have 20 here. Okay. Then I've got 10 options here for digits. I've got 10 options here for digits, but for my last digit, I'm using the number 6. So I've only got one option here, guys. All right. So if I'm looking at this now, what am I saying? 1 times 20 times 20 times 10 times 10. Hey? So 20 times 20 is 400 times 10 times 10. So I've got 40,000. Somebody check me. Check my maths, please. Can you please check my maths? Yes, thank you, Lebo. Okay. So if I want to do the probability now, I'm going to say 40,000 over 8 million. You guys are going to go put that on your calculator. I'm going to go do it quickly. So that's 3, 4, 1, 2, 3, 4. I'm going to have 1 over 200. Hey? Happy? So what's the probability? 1 over 200. Sure, that's crazy. 0.5% chance. Okay, for B, what is the probability that a combination has only one X? What's the probability that it's only going to have one X in it? Okay, so what's the probability that it'll only have one X in it? Well, if we look at it again, 1, 2, 3, 4, 5, 6. So it only has one X now, hey? So one option here, because that's going to be an X, all right? If it only has one X, it means now I only have 19 options here and 19 options here. And I still have 10, 10, and 10 over there. All right, so I've got 19 times 19 times 10 times 10 times 10. All right, guys, help me out, please. Let's do some maths together. Let's go try my calculator. You're going to check me. It's always good to have a check. Is it fair to say 361 000? And so my probability is going to be 361 000 over 8 million. And that gives me what? If I simplify that, what does it give me? Do I get 361 over 8,000? Happy? Cool. And then what is the probability, okay, that it has one or more 6 in it? What's the probability that there is one or more 6s? One or more 6. What's the probability that it has one or more 6? 6s, 6 in this combination. What's the probability that it could have one or more 6s? All right. Well, once again, 1, 2, 3, 4, 5, 6. Here we're going to have 20, 20, 20. Okay. We all good? All right. So what's the probability, guys, that it has one or more 6s in it? How are we going to calculate that? Is it fair to say we could go and say then that we could make this 1, 1, 1? Because 6, 6, and 6. So I've got 20, 20, 20 times 1 times 1 times 1. That gives me 8,000. So the probability is 8,000 over 8 million. So that gives me 1 over 1,000. Okay. All right. Last 2 questions for tonight from Teacher Sam. Last two questions from Teacher Sam. Oh, I'm lying. She's given us an easy and a medium and a hard. Never mind. Okay. She's given us some more. So 5 men and 4 women are seated randomly on a bench. What is the probability that the 4 women will be seated together? So again, 5 men and 4 women are seated randomly on a bench. Okay. What is the probability that the 4 women will be seated together? Hint here. You're going to treat those women as a block. You're going to treat the women as a block. Hi. Let's have a look. So, all right. If we treat them as a block, okay, we've got 5 men, we've got 4 women. So, if we treat those 4 women as a block, there's my 4 women. And here's my 1, 2, 3, 4, 5. So, block, 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 block. Cool? Okay, so I've got 6 blocks. So blocks 6. Then I've got woman 4. Okay, so 6 and factorial times 4 factorial. Okay, If those women were sitting together, all right, how much would that give me? That would give me 17,280. Okay, so that's what it would be if they were sitting together. Okay. If they were just all sitting randomly, okay, if they were just all sitting randomly, then how many people have I got in total? 5 plus 4 gives me 9. 9 factorial gives me 362,880. So what is the probability of the women sitting together? I'm going to take my 17280 and divide it by my total, 362,880. Press on the calculator, see if you can get something smaller. You get 1 out of 21. Okay. All right. We have a few minutes left, and then you have your quiz tonight. So I'm not going to make you do the easy one. You know what I'm going for. Okay. I'm going for the medium one because I'm not wasting your time with the easy one. Let's go for the medium one. All right. I'm going to let you read that through. So give that a read. Okay. Oh, I love these number plate ones. I say I love them, but I really don't. But we're going to give it a go anyway. Okay. All right. So in a certain province, vehicle number plate codes have the following format. hashtag, hashtag, hashtag. 3 letters followed by 3 digits. Where represents a letter of the alphabet and hashtag represents a digit from 0 to 9. Are you seeing a pattern here, guys? Okay. For each number plate code that is assigned to a vehicle, the following conditions must be met. All letters except E, G, and O can be used, and no letter can be repeated. No number plate code can start with a vowel. Yo. Okay. Definitely a medium type of question, this. All right. All digits can be used, and each digit can be repeated. A. How many vehicles can be assigned a number plate code according to the system? All right. Let's start by looking at our letters. Okay, so let's start with our letters. All right, so again, how many letters are there in the alphabet? Okay, there's 26 letters in the alphabet. All right, but what does it say? You cannot use the letters E, G, and O, okay? So you can't use the letters E, G, and O. So 26 minus 3 gives me 23. And then it says, no letter can be repeated. All right. It also says, okay, no number plate code can start with a vowel. All right. So the first letter that we've got can only be a consonant. Okay, so the first letter that we've got can only be a consonant. And what do we know about our consonants? Right, we have, so 20 letters in total. And there are 20 consonants. Consonants. Okay, forgive my spelling. All right. What about digits? Digits can be used and every single one can be repeated, so not a problem. Okay. So if we're looking at our valid number plates, what do we know? We know that the first letter, so here we go, 1, 2, 3, 1, 2, 3. Okay. The first is a letter, all right? How many options do we have for the first letter? Well, it can't be a vowel. It can only be a consonant. And so I've got 20 options. Okay. Then what do I know for my second letter? My second letter cannot be repeated. So I would have had 23 options, but I can't repeat it. So now I've only got 22 options. And my third letter, because it can't be repeated, I have 21 options. All right, now I get to my digits. What do I know about my digits? 0 to 9, 10 options, 10 options, 10 options. Okay, this is tricky, guys. It's a tricky one. This is Maths Lit. Okay, it's a lot of literacy and interpreting the literacy of the maths. Okay, so 20 times 22 times 21 times 10 times 10 times 10 gives me 9240 000. Okay. Now it says, calculate the probability that a number plate code chosen from the number plates available, okay, the ones that we calculated, all right, at random contains one vowel and ends with an even digits. Okay, so now we have to work out, okay, what's the probability that these out of these 9,240,000 number plates, that they contain one vowel, okay, and that there is, what was it? One vowel and ends with an even digits. All right. So let's break it up again. Let's look at our letters. So we weren't allowed to use certain letters in the beginning. Okay, we weren't allowed to use E and we weren't allowed to use O. So that leaves us with A, it leaves us with I, and it leaves us with U. 3 vowels. Okay. We only have, okay, there's technically only 3 positions where those letters can be. Position 1, position 2, position 3. All right. But what do we know about position 1? Position 1 can't be a vowel. So technically, there's only 2 places where there can be a vowel. So second or third position are going to be a vowel. Okay. If I'm looking at my digits, all right, what are the even digits? What are the even digits? Technically, if even digits is anything that you can divide by 2 and not have a remainder. So 0, 2, 4, 6, and 8. That gives you 5 digits here. All right. So let's go calculate what we need to do. Okay. All right. If I'm looking at this, okay, we've really got to think now, guys. Sorry. I didn't calculate this one before because I didn't see the teacher Sam had left it for us. 3 choices, second choice, first letter cannot be a vowel. Okay, so three vowels can be select. Okay, guys, I'm going to leave this one for you to calculate because for us to do this in the next 4 minutes is a lot of time for you to calculate it in. What I'm going to do is I've got the written solution here for you. I'm going to take a screenshot and I'm going to put it in for you so that you can screenshot it. Okay, so that you've got it. And then what I'm going to do is I'm going to tell teacher Sam that she needs to go through it with you for next week. Okay, so I'm going to put it in here for you. All right, because I don't want you to be wasting your time. Let me do this. I'm going to take a screenshot of it. So I'm going to put it in here for you. Okay. And then I'm going to tell teacher Sam that she needs to go through this one with you carefully, just in case you don't understand what's going on in here. All right, because it is a tricky one. Okay, and I'm worried that we're not going to have enough time to go through it. So here's the first part of it. I'm going to make it a bit bigger for you so you can see. All right. take a screenshot. It's really well explained the way it's done it. Okay. While you calculate, while you write, or while you're taking a screenshot of that, I'm going to get the other half of it for you. Okay. All right. What I'll also do is I will put it onto your Google Classroom. Okay. So I will also put it onto your Google Classroom for you so that you can see the solution on your Google Classroom as well. Okay. So it'll be on here. It'll be on your Google Classroom as well. So that you'll be able to see the whole answer. All right, grade 12s. Now, tonight is Wednesday, which means it is quiz night. And quiz night means it's very important that you go and do your quiz, please. Quizzes for MathsLive, they really are beneficial. They show you where you are at, if you're understanding, if you need to do extra work. So please, 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 grade 12s, go and do the quiz tonight. Make sure you know where you're at. If you don't know where the quiz is, please message the helpline because that's really important too. Apologies, this doesn't want to make it bigger for you guys. Come on. Okay, sorry guys. Wait a few extra minutes. Hopefully you've got some time while I make this bigger for you. Okay, doesn't want me let me make it bigger. There we go. All right. So there's the rest.